Today we're going to be talking about graphing using intercepts. And when we're talking about using the intercepts, we're going to be discussing the x and y intercept, or where the graph touches the x and the y axis. And we'll get into that in just a second. But we're going to kind of bridge what we've already done and then connect it with what we're about to do today. So this example here on the popular new math site called MathTunes, math songs or math songs cost $2 and math apps cost $4. You decide to spend exactly $40 from a gift card on songs and or apps. So our first step, write an equation that models this situation. Well, you have $40 and you can buy any combination of apps and songs, and the value of songs, we already talked about that, songs cost $2, so it would be $2 per song, plus it was $4 per app, plus $4 per app. So we have an equation that represents or models this situation. Next step, writing our equation in standard form and then again in slope-intercept form. So I'm going to start off by going with some standard form. So in standard form, I know that it is, well, I'm going to just write it out here, 40 equals 2s plus 4a. I need to set one side to 0. Well, I'm going to set this side to 0 here. And I'm going to have on this side 4a plus 2s minus 40 is equal to 0. Now, when I'm looking at how to translate this into slope-intercept form, I need to identify in this equation here the y value, or in this case, the y value is going to be right here, is the 2s. So if I go ahead and rearrange this equation in the form of y equals mx plus b, I would have 2s is equal to negative 4a plus 40. I'm trying to isolate for the single value of s. I divide both sides by 2, and I get s alone. Negative 4 divided by 2 would be negative 2a, and that would become plus 20. And that negative 2a can be written as negative 2a over 1. It's the same format as y equals mx plus b, except we're just using different variables. When we're graphing our equation to plot all possible combinations of songs and apps, this is how it would look. So if I'm going to basically graph the relationship between songs and applications here, well, my songs represent my y-axis, put that there, and my apps represent my x-axis here. So my first point, I'm going to use this equation because it's a lot easier, as we learned from last lesson, to be plotting our points on the graph anywhere using our slope-intercept form. So when I have no apps, when apps is 0, so there's no apps involved, or in this case, a becomes 0. So this whole thing goes away. What am I left with? Well, I'm left with song value is equal to 20. So my first point here is at 20. Now, I could sit here and plug in every single situation of however many apps I have, plug it in and get an S value. Or I can look at the relationship or the slope that we have come up with when we translated, or pardon me, when we wrote the equation in the slope-intercept form. Well, the slope here is negative 2 over 1. So that means the rise over run is negative 2 and then 1. So I go down 2 and then 1 to the right. So if I follow this along, I'm going to go down 2 and then over 1. Well, if I go down 2, I'm 18, and then I'd be 1 here. So I can technically put that first plot here, which I'm going to. So down 2 over 1 would be right here, somewhere around there. And then from this point, I would move down 2 units. I would move down 2 units and then over 1. So now these are increasing by increments of 2. So I've landed on a very definitive line here, which is 2, and I've landed on another definitive line here, which is 16. So down 2 over 1, down 2 over 1. Each of these boxes represents 2 units, as you can tell from the scales. So I'm going to go ahead and place that second point right here. Now I can keep doing that and following this graph, go down 2 over 1, down 2 over 1. I could very well plot in the middle and give my best estimate, or I can just use this coordinate here. So I'm going to do that. Down 2 or down 4 over 2 would be the same thing. So I have a point here. Then I'd go down 4 over 2. Down 4 over 2. Down 4 over 2. So I'm then graphing this line. Start through here and try to get through them all as best I can. So this would be the graph of these relationships between songs and apps. Well, on this we have the y-intercept, and we have right here, we have the x-intercept, or where the graph touches the x-axis. Again, all this graph is really doing is stating the relationship between how many songs you can have versus how many apps you can have with exactly $40. So you can have 0 apps and 20 songs. You can have 4 apps and 12 songs. That's all this relationship is showing us. So which points would be easiest, emphasis on the easiest, to determine quickly given this situation? Well, the ones that we can see really quickly are the x-intercept, and the y-intercept. So is there a way to find these points quickly just by looking at the equation in standard form? Not necessarily. So if we look at x-intercepts and y-intercepts, the characteristics of x-intercepts and y-intercepts, all slanted lines have exactly one x-intercept and one y-intercept. And we can see that over here. There's the y-intercept, and the x-intercept, or where the line touches the y-axis and where the line touches the x-axis. So the x-intercept is the point where the graph crosses, I said it before, the x-axis. The y value of this point is always 0, right? So if you think about it, when the line touches the x-axis, our y value is 0. So our y value is 0, but our x has a value. The y-intercept is the point where the graph crosses the y-axis. The x value of this is always 0. Again, we have contact on or where the line crosses the y-axis. The x value is 0. There's no x value, but there is a y value. So some quick examples: label the x, y coordinates of the x and y intercepts. I won't do these for all of them. I feel like I'll do like 1 or 2 of these. So if I'm looking at this graph here, my y-intercept is right here, and the coordinates of that y-intercept, well, I don't have an x value, that's 0, but my y value is 2. And then my x-intercept, where I can see the line touching the x-axis, is there. My x coordinate is 4, and my y value, well, there isn't one because it's on the x-axis. And then I'll do the third one over here. My y is here, so my x value is 0, my y is -2. And then my x value, or my x-intercept is located there. My x value is 3, and there is no y value. So for each linear relation, determine the x and y intercepts and graph the line. So our first one here, we have for line A, 2x minus y is equal to 8. Well, zoom in, give myself some more space. If I'm looking for the x-intercept, that's the first thing I'll look for. The x-intercept, I need to set something. I need to set y to 0. So I'm looking for the x-intercept. I need to set y equal to 0. So in this equation, 2x minus 0 equals 8. So that means that there's no y value, so 2x equals 8, x is equal to 4. Or our coordinate is x is 4, y is 0. If I'm looking for my y-intercept, I need to set x equal to 0. So 2 multiplied by 0 minus y gives me 8. Well, anything times 0 is 0. So negative y is equal to 8. I want positive y. Y equals negative 8. Or in this case, the coordinate is x is 0. Y is negative 8. So I'm going to go ahead and plot that real quick. So the first point I'm going to plot would be my x-intercept here, which is 4 and 0. So 4 and 0 is right here. And then my second is 0 when x is 0, y is negative 8. Right there. So I have my 2 points. I'm going to draw my line that goes through. Very roughly like that. So that would be 2x minus y equals 8. So we have our line there. Our next line we have, given to us in standard form, I'm going to be looking for my x-intercept. How do I find that? Well, I need to set y equal to 0. So 3x minus 5 multiplied by 0, we're setting that to 0, plus 15 equals 0. This then becomes 3x plus 15 equals 0. 3x is equal to negative 15. Or in this case, it would be x is equal to negative 5. My y-intercept, set x equal to 0. So 3 times 0 minus 5y plus 15 equals 0. Negative 5y is equal to negative 15. Y is equal to 3. So now I'm going to plot these points. Well, my x is negative 5, that's 0. So that's 1 point. And my other point I'm going to plot would be 0 and 3. So my first point, negative 5 and 0, that's going to be right around here. And then my second point, 0 and 3, it's going to look like this. There. So drawing that line through, our line is going to look something like this. So this would be 3x minus 5y plus 15 equals 0, or a green line here. We do have some special cases of linear relations when a line has only the x or only the y intercept. So with a horizontal line, which looks like this, right, just goes straight across, this line is not going to come down and touch the x-axis. So our slope of this line Is there a slope? No, the slope is 0. There is no change in this line at all. The equation of this line is just simply y is equal to whatever b value or whatever value is on the y-axis at that time. When we talk about a vertical line, when this is going straight up and down, this line does not touch the y-axis at any point. So the slope of this line is technically undefined. So if we think about it, where we get that undefined from, if we know that our slope is our rise over run, well, when it comes to a vertical line, there is no run. So the run is 0. So it would technically be rise over 0. But we know that any number divided by 0 is undefined. Hence why the slope of a vertical line is undefined. Or the equation of this, x is equal to whatever a value that we come across along that line. So the big takeaway here, and what I've seen students have a little bit of issue in the past, is when we know how to find the intercepts. So I'm looking for my x-intercept. I set y equal to 0. Okay, great. And then you get a number. X is equal to 4. Okay, cool. We now need to know that that is technically a coordinate. We already know our y value because we determined it over here. So when we solve for an intercept, be it an x-intercept or a y-intercept, and then we find the value of x, or in this case, we find the value of y, we then need to remember that step of stating the coordinates of that intercept so that we can then plot it on the graph. So that would be the big takeaway from when we're talking about graphing using